Alright, let's look at section 2.6, which is on implicit differentiation. So let's first talk about what implicit differentiation is, and then we'll dive into these examples. So I'm not going to read word for word for what this top paragraph says, but it does say essentially that sometimes you have problems that have x's and y's, or in some cases even more variables than that. We're only going to deal with 2 variables, but and so, you know, we don't need to solve an equation for y in terms of x in order to find the derivative. We can use this method called implicit differentiation to find that derivative. So what we do in that case is we take the derivative of both sides just like we typically would. So all of your rules are still the same. Power rule, product rule, quotient rule, your trig functions, all that is still the same. The only difference is that when we take the derivative of x, we do that as normal. When we take the derivative of y, then we will tack on y prime, or remember that dy over dx is the same as y prime. So anytime you take the derivative of a y value, you're going to add that, and then once you take the derivative of both sides, then you will solve for y prime or solve for dy over dx, whichever one you used as you were working the equation, and then that is your derivative. So we're going to do that in all of these examples, but in the first example and in a couple of the examples, we're also going to find the equation of the tangent line. Well, that's not going to be any different than what we've done in the past, except for typically you would take the derivative and then you would only plug in your x value to find the slope, right? And then you would use then you would put it in y equals mx plus b form. We're going to essentially do the same thing, but now if we've got x's and y's in that final answer, then you'll plug in both x and y into your y prime to find the value of your slope, and then you'll still find the equation of your line and put it in y equals mx plus b. A couple of these want them to be in standard form, and you may not remember that from college algebra, so we'll talk about standard form as we work through these problems. So on example 1, your equation is x squared plus y squared equals 25, and they want us to find dy over dx. That's just your derivative. Again, you can use y prime or you can use dy over dx. So let's start out by finding that derivative. Okay, so we're taking the derivative just like we typically would. So the derivative of x squared is going to be 2x. The derivative of y squared is going to be 2y. But remember, if we take the derivative of anything with a y, then we are going to add dy over dx or y prime. It doesn't matter. The only reason I'm doing dy over dx is because that's what they told us to find in the original. But again, it doesn't matter. If I take the derivative of 25, that's going to be 0. The derivative of a constant is 0. So we've taken the derivative. Now we are going to solve for dy over dx. Okay, so we want everything on, we want dy over dx on one side by itself and everything else on the other side. So I'm going to leave 2y dy over dx. And I'm going to move over my 2x, making it a negative 2x. Again, my goal is to have dy over dx by itself, so I'm going to divide both sides by 2y. They're going to cancel there, leaving dy over dx. So you notice that your 2's cancel, and I'm left with negative x over y. So for part A, they're asking for dy over dx. What is your derivative? So your answer would be negative x over y. That would be your final answer for part A. Now, for part B, they want you to find the equation of the tangent line. So again, if you're finding the equation of the tangent line, you need the derivative, which we've already found. Then you need your slope. So we know that our slope is the same as our derivative, which is negative x over y. So we're going to use this point, and we're going to plug in those x and y values. So that makes your slope be negative 3 over 4. 3 is my x, I'm plugging it in. 4 is my y, I'm plugging it in. So that means that my slope is negative 3 fourths. Okay, so now we are going to put it in your y equals mx plus b. And I think most of you have been plugging in your slope, plugging in your x and your y, solving for b, and then going from there, I think. So that would be 4. This would be negative 3/4. Your x is 3. Double checking, making sure I did that right. I did it different on my notes. I used point slope formula on my notes. Alright, so then that would be 4 equals negative 9/4 plus b. Right, and then move that to the other side. Oh. And so then when you add 4 plus 9/4, I think I plugged in something wrong. Then you are getting, oh, that's right. Then you're getting 25/4. Sorry, guys. It's just like being in the real class. Alright, so 25/4. Okay? Alright, so now we know our y-intercept. You already know your slope here. So that means that your equation is going to be y equals negative 3/4 x plus 25/4. Now, this is slope-intercept form. Okay? And that is the form that we've pretty much been leaving everything in at this point, is slope-intercept form. For some of these, WebAssign wants you to put them in standard form. So you may or may not remember from college algebra, but if you put things in standard form, they want your x's and your y's on the same side of the equation. No fractions, okay? And x needs to be positive. So this would be slope-intercept. But if we were to put that in standard, then we would need to multiply everything by 4 to get rid of these fractions. So that would be 4y equals negative 3x plus 25. And then again, we would want our x's and y's on the same side, our number on the other side, and we do not want our x to be negative. So this would be 3x plus 4y equals 25. And so that is standard form. That's standard form. Okay? So again, let me go back up here where I kind of had a little brain freeze. We plugged in our y, we plugged in our slope, we plugged in our x. When we multiply, we get negative 9/4. Bring that over. 4 plus 9/4, whether you do that by hand or you can again put that in your calculator, it would give it to you as a decimal. And then you can change that to a fraction, would be 25/4. So then we just plugged it in to y equals mx plus b, right, using our slope and our y-intercept. This is slope-intercept form, but if they ask for standard form, then again we want x and y on the same side, no fractions, and we want x to be positive. So that's what we did here. So both of these are correct that are in the box, but it will just depend on what form WebAssign is asking you for. Okay? Alright, so let's look at our next example. Okay? Alright, so example 2. Find y prime if you're given x cubed plus y cubed equals 6xy. So again, we're doing the same thing. Taking the derivative of both sides, but remember, anytime you take the derivative of y, you're going to tack on y prime or dy over dx. since they gave us y prime in this problem, I'm going to tack on y prime when I work this. Also pay attention to the right. This is two terms. 6x is a term and y is a term, right? So this is your first term, your second term. So when we get ready to take the derivative of the right side, then you are going to have to do the product rule as well as implicit, okay? So keep that in mind. So here we go. I'm just going to rewrite the problem. And I have x cubed plus y cubed equals 6xy. Alright, so the derivative of x cubed is just going to be 3x squared. The derivative of y cubed is going to be 3y squared. But remember, when we take the derivative of a y, we have to tack on y prime or dy over dx. And the only reason I'm using y prime versus dy over dx, like in example 1, is because they use y prime here. Okay? Equals the derivative of 6xy, and we're going to have to do the product rule. So the first, which is 6x, times the derivative of the second, and the derivative of the second, which is y, the derivative of y is just going to be 1. But remember, when we take the derivative of a y, we have to tack on y prime. Plus the derivative of, the second as is, which is y, times the derivative of the first, and the derivative of 6x is just 6. Okay? Here, this is first times the derivative of the second plus the second times the derivative of the first. We do not have to stick a y prime if it's just the second as is, right? Which is what the product rule says. Only if you're taking the derivative of that y do you tack on the y prime. So if we pretty this up a little bit before we simplify, we have 3x squared plus 3y squared y prime equals 6x y prime plus 6y, right? Because this one is not necessary. 6 times 1 is 6. And then again, I just prettied that up. So remember, your goal is to solve for y prime or for dy over dx. So I want all of that to be on the same side. So I'm going to put my y primes on the left and everything else on the right. So I have 3 y squared y prime minus 6x y prime equals 6y minus 3x squared. So I left my 3y squared y prime on the left, moved 6x y prime to the left 6y on the right, and then moved my 3x squared to the right, making that negative. So now both of these have a y prime in common. I'm going to factor that out, and that gives me 3y squared minus 6x equals 6y minus 3x squared. If I'm solving for y prime, I want to divide both sides by 3y squared minus 6x. They cancel. And I'm left with 6y minus 3x squared all over 3y minus 6x. Now, I would simplify as much as you possibly can because that'll help you in your next step. And so you'll notice that we can factor out a 3 out of the top and the bottom. And so when you do that, that gives you 2y minus x squared over y minus 2x. Then those 3's cancel. So then your final answer for part A is 2y minus x squared all over y minus 2x. So now this is your derivative. This is your y prime. Okay? But again, part B, they want you to do the same as we did in example 1. Okay? And that is they want you to plug in to find your slope and then find your equation of your tangent line. Okay? So part B, our slope is equivalent to our derivative, right, which we already have down here. Oh, sorry. And so now we're just going to plug in x equals 3 and y equals 3 into my derivative. So that's going to give me 2 times 3 minus 3 squared all over guys, hold that thought. Okay, so over here, I just did not even write this y squared down. And since y'all aren't here to correct me, I'm just trucking along. And that's going to mess us up. So make sure that you, when you divide, that you copy what you have. And then bring that down. Yeah, so I'm missing a y squared. So make sure that you correct that in your notes. Sorry guys, struggling on this second video. Alright, so now plug in 3 squared minus 2 times 3. There we go. Alright, so that's going to give us 6 minus 9 all over 9 minus 6. So that gives us negative 3 over 3, which is negative 1. So my slope is negative 1. Okay, my slope is negative 1. So doing what we did earlier, if we have y equals mx plus b, my y is 3, my m is negative 1, my x is 3, plus b, right? So then that gives me 3 equals negative 3 plus b. That gives me 3 plus 3 equals b. So 6 equals b. So then if I write this in y equals mx plus b, I have y equals negative x plus 6. Negative x plus 6. Now that would be slope-intercept, but if they wanted it in standard, right, then we don't have any fractions, so we don't have to worry about that. But we would want x and y on the same side, and we would still want x to be positive. So this would be x plus y equals 6. Okay, so again, both of these are correct, but pay attention in WebAssign, and if WebAssign wants them in standard, then make sure that you're putting that in standard form. Okay? Alright, so that is example 2. Okay? Alright, so let's look at example 3. Alright, so in example 3, we're doing the same thing, but this time we do have trig function values, or trig functions, in the mix. So obviously that makes things look a little yuckier sometimes, just because it kind of spread things out a bit, but just keep in mind that the process is still the same. It also means that, you know, you're still going to have to do your other rules. So we're doing implicit, but you still have to remember your chain rule, power rule, product rule, all of those rules as we go through this. Okay, so on the left, you'll notice that we will have to do chain rule. This is your outside and this is your inside. And then on the right, you'll have to do the product rule. This is your first term and this is your second term. So keep that in mind as we work through this, okay? So the derivative of the left, the derivative of the outside, the derivative of sine is going to be cosine. Leave the inside the same. And then take the derivative of the inside. Remember, this is chain rule that we learned in section 2.5. So the derivative of x is 1. The derivative of y is 1, but when we take the derivative of y, we have to add a y prime. On the right, we're still taking the derivative just like we typically would, but that is the product rule, okay? So first, which is y squared, times the derivative of the second. The derivative of cosine x is negative sine x, plus the second as is, which is cosine x, times the derivative of the first. And the derivative of y squared is going to be 2y y prime. 2y y prime is when we take the derivative of that first term. That is a y, so we're going to have to tack on that y prime. Okay? So that is the new part. That's implicit, but now we've got to do some algebra and pretty this up a bit, okay? So on the left, keep in mind that all of this is going to need to be distributed through this parentheses, okay? Or through, you're multiplying cosine of x plus y times what's in this parentheses. So cosine of x plus y times 1 is just going to be cosine of x plus y. And then y prime times cosine of x plus y is going to be y prime cosine of x plus y. Alright, then here we're just going to pull that negative out in front. We're still going to leave our y squared in front. So that's going to be negative y squared sine of x plus, and we're also going to pull this junk out in front as well. We usually like to put our trig functions at the end of things. It just kind of helps with confusion of what goes behind the trig function. You know, and then also it's just mathematically pretty. Alright, so now same concept. We want y primes on one side and everything else on the other, so that we can factor out that y prime. So we're going to leave y prime cosine of x plus y. We're going to bring this y prime term over, so that's going to be negative 2y y prime cosine x. We're going to leave negative y squared sine of x on the right, and we're going to bring over cosine of x plus y. And when we do, it's going to be minus because on the left it was positive. Okay, so now factor out your y prime. So y prime. So on the inside, that leaves cosine x plus y minus 2y cosine x equals negative y squared sine x minus cosine x plus y. A little chucky. Okay, now divide all of this by cosine of x plus y minus 2y cosine x. Same thing over here. Cosine x plus y minus 2y cosine x. That's going to cancel on the left. That was the whole point. Okay? So then we get y prime and we have all of this stuff here. Okay? Now, I wouldn't necessarily expect you to recognize this, but you can factor out a negative on 1 on top, and you can also factor out a negative 1 on bottom. And so when you do that, you're left with y squared sine x plus cosine x plus y all over. If we factor out a negative 1 on the bottom, then that gives us negative cosine x plus y plus 2y cosine x. Okay, so our negative 1's cancel. So then that leaves you with y squared sine x plus cosine x plus y all over. And all they're going to do on the bottom is just flip-flop these so that you don't have a negative out in front. And they're just going to write 2y cosine x minus cosine x plus y. We haven't changed the value of anything. We just flipped it around to make it a little prettier so that that negative's not out in front, so that it is in the middle. Okay? Now, as we move forward, you know, you're going to need to pay attention to how WebAssign wants those answers. You know, if we were in class and I was giving you a face-to-face test, which would be wonderful and great at this point, then obviously I would probably be I would be a little more lenient about, or I could be a little more lenient because I would be grading those by hand. But since this is most likely going to be a non-proctored test, then you're definitely going to want to make sure when you're doing your homework and as you review how WebAssign wants those answers, and you want to make sure that you are getting comfortable and confident in how WebAssign wants those answers so that you'll know how to enter them for your test. Okay? Alright, so that is example 3. And we have one more example in this section. Okay? Let's flip it over. Alright, and so we are doing the same thing, but they want us to find the second derivative. Okay? They want us to use the second, or find the second derivative. So we're essentially doing the same thing. We'll have to do it twice, and so there's going to have to be some plugging in that we do on this one. And so you are obvious. We'll walk through that, and when you get ready to do the one on your in your homework, and there'll be one like this on your test, you're going to want to make sure that you're paying attention to knowing how to do this, because WebAssign, again, like I just mentioned, is going to want it in that very specific format, but it's going to work just like this example. So if you know how to do this, then it will work the same way. Okay? So first derivative will not be bad at all. It's going to be the same thing that we've been doing. So take the derivative of all of this and then solve for y prime. So the derivative of x to the 4th is 4x cubed. The derivative of y to the 4th is 4y cubed y prime. And the derivative of 16 is 0. Okay? Now solve for y prime. So we want 4y cubed y prime, and then we want to bring over the negative 4x cubed. Right? Divide both sides by 4y cubed. Cancels. And I'm left with y prime equals, what happens over here? Your 4's cancel, and you're left with negative x cubed over y cubed. Okay? So this is your first derivative, negative x cubed over y cubed. Okay? So now to take the second derivative, you're going to take the derivative of the first derivative, just like we've been doing. But that means to take the derivative of this, you're going to have to do what? The quotient rule. Okay? Because that is a fraction. Okay? So when we take the second derivative, we're going to do the quotient rule. Low d high minus high d low all over low squared. Okay, so that gives us y cubed times the derivative of the top is negative 3x squared minus the top as is, which is negative x cubed, watch your signs, times the derivative of the bottom, which is 3y squared y prime. Don't forget that y prime. All over the bottom squared, which is going to be y cubed all squared. Okay? So again, low d high minus high d low. Alright, all over low squared. So now let's simplify that a little bit. So that's going to give me negative 3x squared y cubed. Negative times a negative makes a positive. Plus 3x cubed y squared y prime all over y cubed squared, power to a power, we multiply, so that gives us y to the 6. Okay, so now at this point you would probably stop here if I wasn't walking you through this and telling you what to do next. Okay, so I want you to pay attention to the fact that we know what y prime is. I moved that up a little too soon. We know what y prime is because we just found it. Okay, so what they want us to do is they want us to plug in y prime. Okay? Plug in y prime because we know what that is. So that means this is going to be negative 3x squared y cubed plus 3x cubed y squared all over negative x cubed over y cubed. Alright? And again, that is all over y to the 6th. Alright, so we do not want a fraction within a fraction, so to get rid of this, we would multiply the top and the bottom by y cubed. Okay? The top and the bottom by y cubed. So I'm multiplying y cubed times this, and I'm multiplying y cubed times all of this, okay? Because remember, that's all multiplied together. So when I multiply negative 3x squared times y cubed, then y cubed times y cubed is going to be y to the 6. So that's going to be negative 3x squared y to the 6. Okay? When I multiply all of this, my y cubes cancel here, but now I'm still left with this y squared, so I'll bring it down, okay? I'm also multiplying plus times a negative, so that's going to make that a negative. And then if I have x cubed times x cubed, that is going to be x to the 6. So this is going to be negative 3 x to the 6 y squared all over y to the 6. Okay? Negative 3x squared y to the 6 minus 3x to the 6 y squared all over y to the 6. Just kidding. I also need to multiply y cubed times the bottom, right? And so what should this be? You're all here. I know that you would tell me this should be what? 6 plus 3 is to the 9th. Okay? So don't forget to multiply that times the bottom as well. Okay? Alright, now do you notice anything on the top? Do you notice any like terms? Okay, we have a negative 3 that is a like term. We have 2 x's here, 6 here, so there's 2 x's in common. There's 6 y's here, 2 y's here, so there's 2 y's in common. So this would be negative 3 x squared y squared. That's what we're going to factor out. So if we do that, negative 3 divided by negative 3, there's going to be nothing here. X squared divided by x squared, nothing here. But y to the 6, pull out y squared. I'm left with y to the 4th. Okay. Negative 3 divided by negative 3 is going to make that a plus. If I have 6 x's and I pull 2 out, I'm going to have 4 left. And if I have 2 y's and I pull them out, I'm not going to have any left. All over y to the 9th. Alright, again, if you were doing this all on your own, I would expect you to stop here and not even think twice about going forward, okay? But now that we've worked this together, just like knowing, okay, we can plug in y prime, I also want you to take note of what we have right here, which is y to the 4th plus x to the 4th, and you'll notice that that is your original problem. So according to the original problem, x to the 4th plus y to the 4th equals 16. So that means I can substitute 16 for y to the 4th plus x to the 4th because they are equal to each other. Okay, so in this step, we are going to plug in from the original equation. We're going to plug in from the original equation. Okay, so now that gives me negative 3 times 16, which is negative 48, I still have my x squared and my y squared all over y to the 9th. But if I have y squared here and y to the 9th in the bottom, our rules about exponents say what? If we're dividing to subtract, so that gives me negative 48 x squared all over y to the 7th. Negative 48 x squared all over y to the 7th. So that is your final answer. Okay? Again, the one that you have in your homework and the one that you'll have on your test is going to be super similar to this. And on your test, especially since it's going to be a web-assigned test on the computer now, and it's non-proctored, then you're going to be expected to make sure you go all the way to that final step. Make sure you go all the way to the final step. Okay? So as a quick recap for implicit, just a few things. Make sure that you remember that when you take the derivative of x's, it's just like normal. When you take the derivative of y, you're going to tack on your y prime. Also, make sure that you're paying attention to your other rules that are embedded into implicit. So it's easy for us to be focused on the implicit part and forget, for example, in that one example where we had 6xy, it's easy for us to forget, oh wait, that's product rule, okay? So you want to make sure that you are taking your time on these. They are a little long and they can be a little tedious, but you want to make sure that you're paying attention and that when your other rules are embedded, that you're doing those as well, just like with everything else that we've done, okay? So the next section is section 2.8. It's going to be on related rates, which is essentially just word problems. And when we do those word problems, implicit differentiation is embedded into that. It's not quite as yucky as some of the problems that we've worked in here. In fact, some of them are just a little more straightforward, or I consider them to be a little more straightforward. But the concept of what we're going to do in 2.6 definitely carries over into 2.8. So you want to make sure that you have a good, firm foundation on 2.6 before you move into 2.8. So that's all for this section, and I will be talking to you soon in the next video. Thanks.